Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper, January 2016. Here we have a loci question to do with complex numbers, so this is brand new to the syllabus. So what we have here is a complex number z and it satisfies this locus here. Find the exact maximum and minimum value of mod z. So first of all, let's look at drawing what we have here. So what we have here is a distance from the coordinate -6, of a distance of 4, so like a radius of 4. So let's draw that on a diagram to see what we've got. So think of it as a graph transformation. If you plus 6 inside the bracket, you actually move it left 6. If you plus 6 inside the bracket as an I, you move it down by 6. So our centre of our circle is going to be at -6, and the radius of 4. So it's going to come all the way out to -2 here. It's going to go all the way up here to -2 as well, out here to -10, and down here to -10. Oh, what a circle. Thank you. So a radius of 4 here. So what we want to find is the maximum and minimum value of mod z. Now what this means, it means distance. Anything with a mod in it is distance. The distance to the coordinate 0, 0. So the minimum distance from the 0, 0 coordinate to some locus point on this line here is actually going to be a straight line that would in fact go through the centre of the circle if we carried it on as well. So this distance from here to here is what we're looking for the minimum, and the full distance we're going for down to here is what we're looking at when we find the maximum. So this coordinate out here is the maximum. So we know that this distance from here to here is a 4, and from here to here is a 4. So if we work out the total distance from the centre of the circle to the centre axis, that will give us, and take away 4 from that, that will give us our minimum point. So 6 squared take away, add on 6 squared, will give me 6 root 2. And if I need to then take away 4, the minimum value of mod z is going to be 6 root 2 minus 4. And the maximum value of mod z is going to be 6 root 2 plus 4. I'm going to leave my answer like that because it does say the exact maximum and minimum value, so therefore you leave the surds in there, you don't write any decimals. Okay then, part B, I'm going to actually do most of part B in blue. What it's looking for is the exact range from minus pi up to pi potentially, but I'm going to find the values for theta, for which the argument from the coordinate 4, -2 does not collide, no common solutions, with my circle here. So my coordinate 4, 2, -2, is going to be out here, 4, -2. So what I want is any angle round from minus pi round to pi, so a 360-degree circle, but that argument must not collide with my circle. So what I want is any angle that's not any angle inside here. Okay, so what I'm going to have to do first is, well, if I work out this angle first, then I'll just subtract 360 minus it effectively. So I'll split my shape like this, and I'll get an x here, and I'll get an x here as well. So I've halved my angle, so I want 2x effectively now. So what I've got here is a right angle triangle, 4 here, and a 10 here. Now luckily, if you remember, if I've got a centre of 6 here and I move up by 4, I've got a coordinate of -2. So this coordinate here is -6, -2. So I've drawn a horizontal line here, and it is in fact exactly horizontal. Both y coordinates are -2. So what I've got here now is a right angle triangle, height of 10, height of 4, base of 10. So I can use a tan angle to find x. and this is going to be opposite over adjacent, and my x angle here, making sure my calculator is in radians mode because I'm working in radians for this question, is 0.3805, and therefore 2x is going to be 0.761. So my argument, if I don't want to intersect with this, is anything on the top. So that's going to be from pi down to 0 at least, but then it can go round from 0 onto the negative angles until it reaches this blue line here. So to work out the point at which it reaches the blue line here, I'm going to do a quick pi minus 0.761. And that will give me 2.38. And so this angle round from here to here is 2.38. But seeing as it's on the negative side here, it's going to be minus 2.38. Okay, so this here is the final answer for the question. Our value for theta, the range of the value for theta can be in between minus 2.38 up to pi radians here. Now I've not included the pi here. There's not an equality on the pi here, because if it was exactly pi, that would mean it would intersect with the circle here. It would just touch it at the coordinate minus 6, minus 2. So I've not included the pi there on purpose. 7 marks for that question.